Okay, ladies and gentlemen, we're looking at section 5.7. Where I have my cursor right now is not an expression, but rather an equation. And a very important difference to know is even though we're going to be using the concept of factoring to help us solve this equation, don't just stop after you factor. A lot of students say, oh look, 4x squared minus 25 is 2x plus 5 times 2x minus 5, and they stop there. Solve means give me an answer for x or for whatever the variable is. So the first thing I notice about this equation is its degree 2, which is called a quadratic. The equation is already in standard form, and that means I have descending power order equals 0. My next step is to factor. I use the difference of squares formula, 2x plus 5, 2x minus 5 equals 0. If two things are multiplied together to be 0, either the first factor is 0 or the second factor is 0, and then we solve the two cases. Here we subtract 5 from both sides and divide by 2, giving negative 5 halves. Here we add 5 to both sides of the equation and then divide by 2. So this quadratic, degree 2, quadratic equation has two solutions, two roots, two answers, negative 5 halves and positive 5 halves. The next, oops, sorry, too far. Oh, now, not, okay, let me use this thing down here. This is sensitive this morning. Okay, here we go. The next equation is also a quadratic. 9x squared plus 1 equals 6x. The problem is it's not in standard form. And in order to get it in standard form, I need this 6x to be a 0 and I need it to be on the other side. So we're going to subtract it from both sides, leaving me with 9x squared. Notice we put the minus 6x in the middle because we want this in the correct order. Of course, the plus 1 excuse me, is equal to 0. My next step is to factor. This trinomial factors as 3x minus 1 and 3x minus 1. But this time, rather than setting up two cases, that would be kind of silly because these are both the same factor. We only set up one case. 3x minus 1 equals 0, add 1 to both sides and divide by 3. So this quadratic equation only has one answer. Now, here's what I want you to remember about quadratic equations. Again, quadratic means degree 2. What this 2 is telling you is at most there will be two answers. Sometimes there's less. Okay? Alright, let's see what the next sheet brings us. 4x squared equals 64. When I put it in standard form, 4x squared minus 64 equals 0. I factor out the GCF, which is a 4. I then have x squared minus 16. X squared minus 16 breaks into x plus 4 times x minus 4. Now, when I go to set up my cases, even though there's a factor of 4 there, I basically ignore it. Because if three things are multiplied together to equal 0, you know for a fact 4 is not equal to 0, so you virtually ignore that 4. 4 equals 0, no it doesn't, forget about it. So you only set the things with letters in it equal to 0. Okay, x plus 4 equals 0 gives me negative 4, x minus 4 equals 0 gives me positive 4. Another way to have approached that problem is you could have divided by both sides by 4 at the beginning, and that would have made 4 disappear earlier. Okay? Alright. 11m squared equals 31m plus 6. The 31m and the 6 we're virtually going to subtract from both sides. They move over to the left-hand side as negatives. Notice the reason we wanted to do it this way. 11 is called the lead coefficient because it's with the m squared. we always want the lead coefficient to be positive. So this is now in standard form, meaning leading coefficient is positive, descending order equals 0. We factor this. Some of you have been taught the AC method. Some of you have been taught trial and error with chin and grin. That's how I teach my students. We know we have 11m and m in the front. We have a 2 and a 3, 2 and a negative 3 to give us the negative 6 in the back. And when I chin and grin it, 2m minus 33m is negative 31m, so we know we've nailed it. We set each case equal to 0. Subtract 2, divide by 11, we get negative 2 over 11. And here we add 3. Okay. And let's look down here. We have a negative x squared minus 7x equals 10. Now remember what I said earlier. Your leading coefficient has to be positive. So I don't want to see a negative in front of a negative 1 in front of the x squared. It doesn't matter what side of the equation 0 goes to. So what I'm going to do is virtually add this and add this to the other side. So I have 0 equals, and when these get added, i.e. some of you say move them over, but what you're really doing is adding them to both sides, we have a positive x squared, we have a positive 7x, and the 10 is still positive because we didn't move it, okay? So now what we do is we factor, and we use the FOIL method in reverse because this is a trinomial. So we have x plus 5, we have x plus 2. Chin and grin works. 5x and 2x give me the middle term of 7x. When I set each factor equal to 0, my first case gives me the answer negative 5, and my second gives me the answer negative 2. Okay, this is the first video for 5.7. I'll make another one in a minute.